All right, welcome everybody to BS Friday, where each week we bring you the stories behind the building science. And today, hosting Nikki Kruger on the topics of dehumidification and ventilation. Well, isn't that just a breath of fresh air? We're talking about how humidity works, the building science behind humidity control, and why temperature control and humidity control are not the same thing. All right, well, enough said. Let's welcome Nikki to the show. Nikki Kruger, how are you?
Good, good. How are you doing, Dave?
Man, I am awesome now that you're here. You're going to help me control the humidity in my house. You're going to help me control the bacteria in my house. It's going to be healthier. It's going to be safer. And for everybody out, 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 for everybody.
Oh, I think we had some technical difficulties there.
Hi, can you hear me, Nick?
I can hear you.
I am not sure where I went, but here's where we're going to go with this. Nikki, you go right ahead, and I want you to tell everybody about who you are, where you come from, what you do. We want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will have somebody on the show that knows who you are, and it will go all downhill from there. Cool?
Oh,
let's do it.
You're back. All right. So yeah, my name is Nikki Kruger, and I am the Director of Marketing and Business Development for Santa Fe Dehumidifiers. I actually have a background in communications and somehow ended up getting into the technical side of HVAC, more specifically on controlling moisture and applying ventilation to homes. And that moisture control might be the attic, the whole house, the crawl space, or the basement. So I think the best way to kick us off here.
Excellent.
Oh, go ahead. Is I think.
No, that's excellent. What happened there? Things just shut off and went to all kinds of space and back, and here we are. So if you wouldn't mind, let's hop into the presentation. Let's walk through some of this, okay. And I look forward to it. Here it comes.
All right. Well, it's very, very confusing, I think, sometimes because we talk about so many aspects of humidity, whether that be relative humidity, dew points, how it applies or is directed by temperature. So on the bottom left here, I pulled these all. These are maps from today. On the bottom left, we've got a relative humidity map across the United States. And typically when we're talking about the need for dehumidification, we talk about green grass climates. So anywhere that you're getting about an inch of rain or more during the spring, summer, and fall, you're probably going to need some form of dehumidification in a single family home. And I say single family because when we talk about multifamily with apartments, there is a chance, even in a drier climate, that we might have to apply some dehumidification just because of occupancy, moisture generation that's going on. But typically, if you took a climate zone map and you looked at that map and it said, okay, everybody, everywhere from usually I think it's about Kansas, Oklahoma, over east, that's moist. That's the moist area of the United States. And typically I wouldn't have said Oklahoma for dehumidification, but there was a week this past summer that Oklahoma City saw an 83-degree dew point. 83-degree dew point in Oklahoma City.
Wow.
That means wherever it was 83 degrees or less, we basically were going to be hitting condensation on a surface. So yeah, that's crazy. That's crazy. But you can see we have high relative humidities through the Midwest, through the Mid-Atlantic there today. But you can't talk about relative humidity without knowing the temperature. So on the map up on top, we've got temperatures that are going across. So relative humidity is relative to a temperature. And basically it's telling us how the percentage of moisture that is in that air. You hit 100%, you're probably going to be raining. So we've got some areas that raining across the United States, obviously there today. What even tells us even more about how much moisture in the air is when we get to that dew point map. And that tells us, okay, at what temperature are we going to hit condensation? So fall is a great time to really show condensation, because a lot of us wake up in the morning, look outside, and our grass is wet. And that's because the temperature has hit the dew point, and that's why we have condensation on our grass. Condensation is where we're going to get typically on our ductwork potential. If that dew point hits that temperature, we're going to get condensation in our crawl spaces. If we have a vented crawl space and air's coming in, we have potential of hitting condensation in our walls. If we've, haven't sealed our ribbon bands well, any air infiltration coming into our homes, we've got the potential for condensation. Now, relative humidity is important, because although we might not have condensation, if the relative humidity is high, we get moisture loading. So starting in the spring, it's raining. Probably not a lot of AC runtime going on. So our materials in our homes start loading with moisture. The drywall, the carpet, the mattress, the couch, all that starts collecting the moisture that's in the air. Wow. Then summer comes, and depending on how tight your house is, hopefully that AC is running longer periods of time, or you have a dehumidifier and we're removing that moisture. Come fall, and this is where I'm very busy right now and seeing the evidence, is the AC shuts off. We have high dew points outside, and a lot of materials in our home just can't take that moisture loading anymore. And that's when we start seeing the microbial growth and that evidence of moisture loading. So you don't have to hit condensation to and have a wet surface in order to get microbial growth. It's that moisture loading that's going to happen.
I always use the analogy of, like a glass of water in the summertime when you're inside and you have a glass of ice water, and then you take that glass of ice water outside, you sit on your back patio, you set it down on the table. All it does is sweat, because you've taken now that cold air and hot air. And if I'm reading between the lines, the same thing's happening between the walls of our houses.
Absolutely, it can happen.
The humidity level is up so high, right? Somewhere there is that break. If there's no thermal break, somewhere that cold and hot's meeting, and that's what's causing all this condensation.
We're getting that dew point temperature. Yep. And so when we have, our vented attics, and we're putting our ductwork and our HVAC system up in a vented attic, and we've got that air coming in, in the crawl space, the same thing. We see a lot of the ductwork in the HVAC systems and crawl spaces. And you might have those vents, but air doesn't come in one vent and automatically go across and go out the other vent. That's not how it works. What happens is typically the air is going to come in through those vents, and then hot goes to cold, and wet goes to dry, and high goes to low. And basically 50% of the air that's below that home is going to make its way into the living space, and it's going to condensate, produce condensation on that ductwork, water pipes, that sort of thing. And potentially you got rain in your crawl space.
In the crawl space, and in your house for that matter.
Potentially. I mean, there's no doubt that we see a lot. And I hear this a lot in the Northeast, where, people are like, every year my shoes are in the closet and my leather shoes get moldy, and I take them out and I buy a new pair. And, they just don't realize that you can control that moisture in your house, and you don't have to replace your shoes, and you don't have to replace your valuables, because if it's doing that to your clothes, potentially what it's doing to your building materials and your foundation, your health, your comfort is probably worse.
So when we look at the houses that are out there today, and we'll get back to the presentation, because you're probably going to answer these questions somewhere along the way.
That's okay.
But, older homes, obviously we have a lot of older homes out there that are built the way you said, where there's uninsulated ductwork in the basement, uninsulated ductwork in the attics, and then you live in climate zones where you have cold and hot and everything else in between. what is how do you control the humidity in a 1970s crawl space or a 1970s attic, when the rest of the house isn't built, tight.
Yeah. And that's one of the things that we don't look at a moisture issue and say, oh, a dehumidifier is going to fix that.
Yeah.
I mean, we have to look at the house as a system, and there are some steps that are going to have to be taken in order to apply a dehumidifier. Otherwise, it's just going to run all the time.
Right.
So we've got to try to air seal as much as possible. And the reality is that air conditioner is probably just running for full bore. It's removing moisture, but unfortunately, as fast as it's removing it, it's bringing it in. So we've got to tighten up that house as much as possible before we can apply a dehumidifier.
You said the house is a system, right? Like we're thinking of it as a system. Can you break that down a little bit?
Sure. So, when we look at our air barriers and our insulation and ventilation and our mechanical systems, it all has to be looked at holistically. So we need to know that if we have a lot of holes and a lot of air coming in, in order to get our HVAC to work correctly, in order to be able to have healthy air in our home, so we know where that ventilation is coming, the air is filtered. We've got to be able to look at the entire building, home as a system, and figure out, okay, what are our steps in order to make sure that we are creating an energy efficient, comfortable, healthy home. Well, and air sealing is going to be, number one.
Go buy yourself some caulking and get to work.
Figure it out. Get a blower door test done, figuring out where your leaks are, and getting it sealed up. Now, once we get it sealed up, then we're going to have to look at, well, how tight is it? And then, we should be bringing in some sort of mechanical ventilation and filtering that air that we're bringing in.
So once you get through, like understanding what it is, like from a ventilation and dehumidification system, when most of the world's looking at a retrofit versus new construction right now, right?
Absolutely.
Where do they start? Like where, sorry, we can start getting caulking and like, but really what's the first step for a DIY or homeowner? Because nobody trusts contractors out there. And the unfortunate truth is, the guys that really got it figured out, like the Jake Brutons and the Matt Reisingers and all them, there's more than a handful of them, and a lot of people follow them, but it's hard to find those people that really understand it and get it. Where can they start? What would be your tips?
My tips is the Home Performance BPI Institute. They have a lot of trained and certified weatherization people that can come out to your home. They can do a blower door test. They can do a duct blaster test. And they are. You go on their website and you can put in your area and they will come up. And, they are fairly affordable, especially if you look at the benefits of what you're going to get in energy savings from being able to tighten up your home, but also just from a comfort and health perspective. And that's where I would start, is learning that.
Well, that's it. So many people just don't realize that their homes are what's causing them to have migraines, that their kids have allergies, right? And it's real easy to go see a doctor and a doctor says, well, you have allergies and X, Y, Z. But sometimes the source of those allergies are starting because of the bad bacteria and things that are happening within your ductwork in that attic or in that crawl space that you really don't know what's happening. You just know you love the heat and you love the cold air in the summertime. So,
so 80% of the people who have indoor allergies are allergic to dust mites. And it's not the dust mite, it's the fecal matter from the dust mite. And soon as you lower that relative humidity below around 55%, they go dormant. So, and that is so important because a lot of times those dust mites are, in bedrooms, in your living room couch area, but especially in bedrooms. So getting that relative humidity controlled is extremely important. for health.
Yeah, for sure. So I'm going to put your presentation back up here. Is there some more things I believe you want to run through? Yes.
Absolutely. So there's so many things that can lead to a high humidity in a home. So first of all, a tight house. When we tighten up that house, yes, we're keeping out the infiltration from the outside, but as soon as we do that, we got to bring in some sort of mechanical ventilation. And usually that's going to bring some moisture with it. A leaky house, that you're going to have to do some air sealing for sure. Construction drying, that's one that a lot of people don't think about. But when you close up a home in construction in the spring or fall, you're trapping a lot of moisture on materials that have probably been rained on. So we have usually 2 to 3 years of drying of materials when we build a new home. If you got a crawl space, basement or attic, you're going to have some humidity, a lot of wood. Now, low loads, and that's what we're seeing more and more, even with code built homes. We just don't have the AC runtime on our homes anymore because we're building them so tight, which is great. We want to build them tight to run the largest mechanical device in our house as little as possible, but that's the device we're counting on to remove moisture. So when we say low load home, that's a low sensible load, which is basically the temperature, right? It's not a low moisture load, it's a low sensible load.
Everything you're saying here leads me right back to my world. And this is why we should be doing more offsite construction with dry kiln wood. Are you kidding me? 3 years for my house to dry out so I
3
don't
years.
have.
And I think I've even heard longer on that, but yeah, typically 2 to 3 years for the materials to dry.
That's like a record scratch. I mean, it's to me, it's insane, and it causes all these health issues, and I think, hey, it is what it is, and that's where we're at today and what we have. But lucky we have you on the show to tell us how we're going to resolve some of these issues. So let's keep going.
All right. So mechanical ventilation, our HVAC equipment is very energy efficient. And when we say it's energy efficient, again, it's energy efficient at getting to that set point on the thermostat, which means I'm gonna get there as quickly as possible and probably not get the runtime I need to get the moisture out. High dew points, mild temperatures. The wild card in every home is the people.
Yeah.
Right? We can design it, we can install it, commission it, everything's perfect. And then you put people inside and then all bets are off, because what I want the thermostat at is very different than what my husband wants the thermostat at. So, as soon as you give people control of that thermostat, then all bets are off.
I control the thermostat. Like yeah, we have a thermostat battle pretty much weekly between all of us in this house.
And if you look at all these things, because a lot of times people are like, I don't know where the moisture is coming from. And the reality is you might never know, because a little bit from every single one of these can add up to a lot. So you might not ever be able to pinpoint exactly where it's coming from. So, when we look at our HVAC systems, we're asking a lot of them. Usually people are like, that thermostat is up and down numbers. I want it to provide heat or I want it to cool my house. But the reality is we're counting on these systems to do a lot. Heat, cool, dehumidify, humidify, purify that air, ventilate. And and I want it in every single room of my house, 24/7, 365. And can you use as little energy as possible? And so, what we really focus on is, how do we get that AC system and a dehumidifier with ventilation to be able to achieve what we're after during the spring, summer, and fall. And what we're after with these systems is comfort, health, property protection. If you're a builder, liability protection, contractor, liability protection. And again, can we do it as energy efficiently as possible with the systems we're installing? So, when we say HVAC, we got heating, air conditioning, ventilation, and conditioning that air. But, what we automatically assume is that the air conditioner is going to be dehumidifying. And we really need to be adding that D into this HVAC D system now to be thinking about that.
So when I look at this, the big one that stands out to me is liability. And as we're getting into, healthier homes, building healthier homes, more environmentally friendly homes, and the codes are changing, is liability going to be an issue for builders or for mechanical contractors if they don't get it right?
Well, I don't know if it's necessarily they'll have direct liability, but they're going to have callbacks.
Right.
As soon as somebody's not comfortable in their home, and I've been involved in a lot of communications where I've got a builder, an architect, an energy rater, the
Mhm.
homeowner, the HVAC contractor, all on the phone because there's a moisture issue and everybody wants to point fingers at somebody else for the problem. And the reality is everything was probably done correctly. We just didn't add that dehumidifier. We built it tight. We used a super energy efficient HVAC system. We're bringing in ventilation. We've done everything correctly. We're minimizing the runtime on the air conditioner. We sized it correctly, but we just don't have the loads. And so we need something to be able to remove that moisture. Moisture is the number one detriment to every building.
Sure.
And so, that water vapor is no different. It's just in a vapor form versus bulk water form.
Yeah. So obviously the homeowner has a lot to do with how the house operates and how it runs once they take over. And, once you let the horses out of the barn, you can't control what they do with temperatures and humidity and how they're using it. But who's training the homeowner on how to use the systems or what to ask for or what symptoms or signs to look for before it becomes a problem for them?
Yeah, and that's very challenging. Is the education aspect, right? I mean, a high performance home has to come with instructions.
Right.
People need to be educated on how it all works because that HVAC system is designed specifically based on how that whole home was designed. And so they need to understand if they have an ERV, well, what is the purpose of that ERV and how is it running? How's my ventilation working? Oh, I have a bath fan. So I go in, I turn it on, and then I leave the bathroom and shut it off. No, it should run for probably 20 to 30 minutes after you shower in order to remove that moisture. So there is a lot of education. I was involved in and even more challenging is multifamily. I was involved in a project a couple of years ago here in Northern Virginia, where they put in 2-stage HVAC systems to try to handle the moisture in these apartments, and there wasn't any education to the residents, and so by the time I got called in, there were signs of microbial growth, and the resident, all she knew is she was uncomfortable. So she just kept going over and cranking down that thermostat because it was humid. And these systems were way oversized for these apartments. And by the time we got in there, I think she had it set at around 66 degrees and the RH was over 70%.
Yeah.
And you just don't know because that's my comfort control center, right? All I know is buttons up and down and
Right.
I'm uncomfortable. That's like in the middle of the night when people get up and crank down the thermostat. It usually isn't a temperature. It's usually because it's a moisture that's creating them to be uncomfortable. So education's a big part of how these systems have to run.
Is it mandatory now, or is it going to be mandatory in the future that there is a humidity control system in every install moving forward?
So we are starting to see, like we have Indoor Air Plus
Hmm.
program, the EPA Indoor Air Plus program, and they are recommending that you have a dehumidification strategy
Right.
as part of their program. Now, usually these strategies, they give you options, and one can be an HVAC system with dehumidification mode.
Okay.
Now, what that means is that it will overcool, usually 2 to 3 degrees, so run longer in order to remove moisture. Now, you still have to have a load for it to run. So that means that you have to have a need for cooling. If we looked at, bring that temperature map, temperatures are pretty mild right now in a large part of the United States. There's not a lot of AC time or runtime going on right now. So overcooling when you don't really need to be cooling to control moisture in your shoulder seasons overnight is going to be a challenge. So they do recommend a whole house dehumidifier or a dehumidification mode on the AC systems.
Sure.
But again, a lot of people don't understand what that means. They're like, oh, well, my air conditioner has dehumidification mode. Well, it has overcooling mode is what it usually has.
Right.
And you can create, uncomfortable and by overcooling a little bit, or you have the potential again of hitting condensation if it overcools to a temperature that, Rusty registers in Florida.
Right.
We see them all the time. Well, we now got this really cold air that's hitting metal, and we've got condensation and rusty registers.
So you're going to yell at me. Don't yell at me.
All right.
So we did, it was just literally last week, the other night, right? It was warm during the day. And I'm like, I just can't go to bed. I mean, it's just too hot. So we turned down the AC, left the AC on, fell asleep, woke up, and I had condensation all over my windows, like to the point you couldn't even see out, right? Because it was still humid and hot outside. So, I mean, it happens to the best of us even, right? And I'm just renting a place. I haven't even built a place here in Pittsburgh yet. We just moved back. But, I mean, if it's happening to me and I do this and talk about it all the time, it's got to be happening across the country in a big, big way and really causing a lot of problems for people.
Well, and my guess is that condensation was on the outside though, right? It wasn't on the inside. It was on the inside.
Yeah.
Oh, wow. Because that's usually something you see in the winter time is the condensation on the inside of the windows. But yeah, not something you usually see this time of the year. So that's very interesting.
Well, so I also learned since that night, because I went and checked, because I was asking the same question, the humidifier downstairs was still set to a winter height, to keep the heat and the humidity in here.
Yeah.
So if it's running, it was pumping water into the air as well.
Oh boy, you had a lot going on.
I'm telling you, between my teenagers in the house that like their temperature, it's an interesting place to be. And we're probably like the best petri dish in town.
Well, and then, Indoor Air Plus does require a closed crawl space as part of their program because they recognize that, making sure that we're not bringing in air from below the house that potentially has contaminants is very important. Right. So there is a lot that we're starting to see in these programs, Energy Star and Net Zero and Indoor Air Plus, and even in some areas in Northern Virginia, Delaware, for multifamily affordable housing tax credits, they have to either leave room for a dehumidifier or install one as part of their tax credits for multifamily affordable housing. So they are recognizing that, yes, it is going to use energy, but ultimately the benefits that you get, we can't just be chasing energy efficiency.
Right.
It can be the most energy efficient home or multifamily complex, but if no one can live in it, it doesn't matter.
That's right.
So when we design our HVAC systems, we're, the Manual J, which is the software program that hopefully our HVAC contractor or mechanical designer is using, but, they're trying to achieve with that air conditioning system, a 75-degree temperature and 50% relative humidity. So that's the interior conditions that they're striving for. And then they size it based on the peak load condition that your area is going to see outside. So peak load, like let's take Atlanta. Peak load, I think is 92 or 93 degrees in Atlanta. So I'm going to size my HVAC system based on worst case scenario for outside. Now, do you know how often that peak load condition typically is going to happen in your area?
I personally have no idea, but I see somebody in the comments, James Dean, he lives in Atlanta. And guess what James does? He's also in the education space and educating the world for stuff like you're talking about. So
Perfect.
maybe James can Google search it real quick and put it in the comments. But we're going to get to everybody's comments here in just a few. Adam White, Greg Ugaldi. Oh, you got the past chair of the NAHB comment.
Oh boy.
He's making snarky comments.
Uh-oh, yikes.
Uh,
But typically you're going to see that 1% of the time. So we design our comfort system based on 1% of the time. Mm-hmm. So what are we going to do the rest of that time in order to ensure that we've got especially 50% relative humidity? And that's very challenging. That's our shoulder seasons, our partial load, which the tighter our homes get, the more partial loads that we're seeing on our systems.
Right.
All right. So here we go.
One of the things that we do on the show a lot is talk amongst ourselves. So when we talk about partial loads, to break that down for the consumer that's watching this, right? That basically means if you're building your house right and you're building it tight, right? There's a good Etienne Gubler saying right there, build it tight, build it right, all that fun stuff. It puts less load on the mechanical equipment that you have in your house, which also increases the longevity of the equipment. It increases the quietness in your house because you don't hear fans or anything blowing, which you don't hear much now anyhow, the way things are set up. But I just want to clarify some of these things. So we do want to educate the population out there, like the consumer, so they can ask for a better product.
Yep, absolutely. And partial load is just exactly what we have up here. This is Mike Barsick from South Face down in Atlanta. Worked with a gentleman to put this data together. But if we look at the first arrow down there, our manual J design load is 92 degrees. And so, but our ASHRAE humidity design, so that means when are the highest dew points in Atlanta? And that's when it's around 82 degrees. So that's a partial load. That means we're not running full blast on our AC when it's 82 degrees out. We're running full blast at 92 degrees. And across the top there, we've got our bin temperatures. And, 83% of the time down in Atlanta, Georgia, we're running at partial to no load conditions on that AC system. So we're just not running very often in order to be able to handle that moisture that we have in the home. Now, we have high humidity outside, but people generate moisture. So each person generates about a quarter a pound of moisture an hour. So if you got a family of 4, and a pint's a pound the world around. So if I say a pint of water or a pound of water, they mean the same thing. So, each person generates about a quarter of a pint of water an hour. Family of 4, 2 pints or pounds an hour when we're home. And now, when we were home with COVID, there was a lot of showers, a lot of cleaning, a lot of people home for extended periods. There was a lot of moisture being generated in our homes during that time. But so we got to deal with the interior moisture loads as well. Teenagers taking long showers, that's going to happen. So that's what's outside and coming in, and then basically what we're generating on the inside. So here it's saying at the very bottom there, if you were using bringing in like 100 CFM of outdoor ventilation air, either mechanically or potentially just from infiltration, you've got about 93 pints or pounds of water removal that you're going to need a day.
No kidding. A pint a pound the world around. That's what you said, right?
A pint a pound the world around. Yep.
I'm gonna have to make a T-shirt for you on that. So you're telling me that we're generating, if I have a bunch of holes in my house like new construction does these days, right? You're telling me a new constructed house that isn't built, with the professionals that we're used to seeing and talking to on this show, that they probably have enough air leakage that it's creating almost a pound of excess water in their house a day?
Oh, it's more than a pound. I mean, it's the infiltration that we're getting And again, it all depends, I would say, on, what building code year you're on, because we are getting more advanced in our building codes and creating tighter homes and requiring blower doors and trying to get to that, and I'm going to throw it out and, 3 ACH50 or 5 ACH50, but understanding how much air is leaking into our homes.
Right.
But the more you can minimize that infiltration, the better we can control our environment, right? If we minimize what's coming from the outside in, and we use mechanical ventilation, then we know where it's coming from and we can filter it. And then hopefully we can temper it or treat that air as well, as part of our mechanical system. So, but it's challenging in existing homes to be able to do that. But it's something that as we build new homes, we should be thinking about. So again, here's this partial load that we're talking about. My friend Kimberly Llewellyn from Mitsubishi put this data together, and it's fabulous. So basically it's saying if you're between 50 degrees and 80 degrees, that's not a lot of AC runtime going when we're especially at 50 degrees, and you have a greater than a 55-degree dew point. ASHRAE wants us in our homes to keep it around a 55-degree dew point during the spring, summer, and fall. These are the amount of hours during the year that you're going to be at these conditions in some of these key cities. So Miami, you got 4,375 days of the year that you're at partial load, not running a lot of AC. The one that people are always surprised about is the very bottom, Phoenix. They're like, what? Phoenix? You're going to need a dehumidifier? And when I first started working for Santa Fe, I got a call from a gentleman in Phoenix who wanted to order a dehumidifier. I'm like, no. You want a humidifier. He's like, oh, you don't understand monsoon season down here. And I'm like, no, I don't. But yeah, so it's interesting to see that, if we're counting on our air conditioner in these humid climates, I mean, Mobile, Alabama, to control the humidity, we're going to have to think about a different strategy in order to keep our, our homes protected and our health and our comfort.
Sure. So
any questions going on that we should be addressing here yet, or?
Well, I mean, there's some comments there, but I think let's try and get through what we have so we keep everything to the end.
Okay. So basically, AC, our thermostat's designed to get to that sensible. Dehumidification is really just kind of overcooling. And, you need 14 minutes of typically runtime for those coils in an air conditioner to start collecting the water. And that's before one drop of water goes down the drain. So really you want about a half an hour of runtime on your air conditioner when it is running to really be able to remove that moisture and hopefully keep you at a safe relative humidity in the home. So we talked about how energy efficient our AC systems are getting, and that's referred to oftentimes as the SEER, the seasonal energy efficiency ratio. So, what's the SEER of that HVAC system? And that's basically what they're telling you is how energy efficient is it? And the more energy efficient we get, you're going to see in some data here, typically the less water they remove because they're so efficient at getting to that temperature quickly. They have larger coils, and those coils hold about a pint or a pound of water per ton. So if you have a 3-ton AC system, when those coils are loaded, you got 3 pounds or pints of water on those coils. They don't get as cold. Those coils don't get as cold as they used to, so less water removal. And then they've kind of figured out a way to cheat the system a little bit. When the compressor shuts off, they'll run the fan 1 to 3 minutes after the compressor shuts off, and they get points for evaporative cooling. So basically that fan is blowing the water that's on those coils back into the home. And they're getting, if you live in Phoenix, again, evaporative cooling isn't a big thing. If you're down in Mobile, Alabama, you don't want evaporative cooling. So most of the systems now, they give you the contractor, the HVAC contractor can shut that off, but it can increase the RH by 10% in the house. So
how we tracking all this? Because once they install it and leave, like, again, I get back to, like, how does the homeowner know this? Is it all because of the little control station? They just have to have the right thing sitting up there?
my guess is the first thing is they're going to be uncomfortable. I mean, even before you get that little control station, you're buying that control station because you've already experienced, you're uncomfortable, right? You want to know what's going on. Something doesn't feel right. And that's basically how these calls are made to contractors, because there's a problem. We rarely, I mean, it's happening more and more that builders are automatically just speccing our dehumidifiers. I would say, the high performance builders, the semi-custom to custom, those are the ones that get it. But typically we're called in to solve a problem with a dehumidifier. Sensible heat factor. All I'm going to say is this tells you how effective your AC system is at removing water. So when we look at this data here, I've got a 2 3/4 ton system here that's 14 SEER. So not the most energy efficient AC system on the market.
Right.
But when it runs, it's removing a bunch of water. And I can tell that by this number here, the sensible heat factor. When it's running, 62% of its BTUs are going to cooling, and 38% of its BTUs are going to removing water. So when this system's running for an extended period, it's cranking away. It's cooling your house and it's removing water. If I go down here, I've got a 1/2 ton mini split. 33 SEER. That is very energy efficient, extremely energy efficient. When it's running, 96% of its BTUs are going to cooling and getting to that temperature on the thermostat, and 4% is focused on removing water. That's why their condensate lines are like the size of a pencil, because they just don't remove a lot of water when they're running. They're so energy efficient at getting to that temperature.
Right.
So a lot, when I get calls from contractors or builders or homeowners, they've got a problem, I'll oftentimes ask for their manual J. And then I'll ask, do you have the sensible heat factor or ratio, that it's the same thing, of your HVAC equipment, so I can get a better idea of what they've got going on in their home and how we can tweak and adjust and, potentially add the right dehumidifier for their home.
Once all this is installed in somebody's house, are there systems that can automatically manage that for you when you set it? So a homeowner doesn't really have to think about it. You kind of set it and forget it. I mean,
with a dehumidifier, you should never have to. You set it to 50%, and that's it.
Yeah.
If it gets above 50, then it runs. If it's below 50, it doesn't run. I mean, people always think, I want your dehumidifier to, have an app on my phone because I want to be able to control it. I'm like, no, you don't. You don't. You think you do, but you don't, because you just set it and forget it.
Right.
So we get this question quite a bit, or I should say I get this statement quite a bit. We put in a variable speed air conditioner and it's a dehumidifier. And, I'm from the Midwest. But I've spent a lot of time in the South, and I've picked up this saying, bless your heart. I just don't argue with people anymore, because the reality is, and I think you've met Brian Orr from HVAC school.
Sure.
I wrote an article for Green Building Advisor, and Brian did a really good job with this quote here. But basically, what is happening with these variable refrigerant AC systems that say that they can do a really good job of removing humidity is the closer they get to the temperature that you're asking for in your house. So I want 75 degrees. So it starts out at 78 in your home. The AC comes on, it gets closer to that 75 degrees. and it decreases the compression ratio in that compressor. And it doesn't get as cold for your coils anymore to actually to have condensation remove water. So one of the ways that Brian explained it to me is, okay, I'm at 78 degrees and I start running and I've got a sponge that's full of water. And as I'm running, I'm squeezing out that water in that sponge. But as I get closer to that temperature that you want, I can't remove very much more water anymore because the temperature isn't as cold as you need it to be. So I'm still wet, right, but I'm not squeezing out any more water. So, and we get this a lot, you know, actually this project I was just down in Texas, they put in variable speed. They can't understand this time of the year. Why isn't it controlling the humidity? Well, first of all, it doesn't need to run very long. You've got really energy efficient apartment buildings, and it just doesn't remove the humidity that you were told that it was going to remove with that equipment. So I think this is a pretty important slide here that, you know, when we look at low load homes, they're really low sensible homes. And traditionally, you know, we would just size an HVAC contractor would size the equipment by pulling up to the outside of the home and say, you know, okay, what is this house? You know, and they'd hold up their fingers, 2 tons, 3 tons, 4 tons, just guessing, right? Rule of thumb. But now as we start getting our houses tighter and tighter, we're seeing that we don't need that much AC. And so with Energy Star, you know, typically you're around 1,200 to 1,600 square feet per ton. A net zero home, you're at 2,000 to 3,000 square feet per ton of AC cooling. You just don't need as much as you used to, and right sizing is super important.
I love it.
All right, install matters. So I get calls every single year where I get an HVAC contractor that says, your dehumidifier is a piece of crap. I put it in 2 weeks ago and the RH has actually gone up in the house. And so my first question always is, how did you install it? And typically they install it on the return side. So the supply of the dehumidifier, they're putting it on the return side of the HVAC system. And that is not the correct way to do it. We want to pull a dedicated return, if possible, to the dehumidifier and then tie into the supply side of the HVAC system. And the reason we want to do that is because when you put a dehumidifier on the return side of the AC system, a dehumidifier is going to generate some heat as a byproduct of removing moisture. And that heat is going to heat the coils of that AC system.
Yep.
And that AC system is going to remove less water. So when that air conditioner is running, we want it to remove as much moisture as possible. It's the king. AC is king and the dehumidifier is queen. So when the AC is running, let it remove as much moisture as possible. The other problem with that is that when the AC shuts off and those coils are loaded with moisture, the fan from the dehumidifier is going to re-evaporate it back into the house. And so that's why we will see the relative humidity actually go up in the home when a dehumidifier is added this way onto a system.
Yeah. You know what? Actually, one of the comments is really relevant to this. Let me just put it up here real
quick.
James Dean, an HRV can help dry out the building materials in new construction, then switch the core to an ERV to help keep RH between 40 and 60%.
And in some climates that will work. But an ERV is always going to contribute to the moisture load in the house. It will reduce it, but it's going to be based on how humid is it outside and how humid is it inside. The bigger the difference,
right,
then the better exchange you're going to get. But it will always add moisture to the home. And so a lot of times we have a lot of builders in humid climates that will put in an ERV and then just they won't use the ventilation part of the dehumidifier. They'll use the dehumidifier just to control the relative humidity. Armin Rudd did a study with the DOE, and basically it said, when it's humid outside and humid in the house, you're going to get very little exchange when that ERV core, when that's happening. It'll help. It's the Cadillac. Put in an ERV and a dehumidifier, and you've got the Cadillac system.
Cadillacs used to be the most popular cool vehicle back in the day.
So, crawl spaces is a big one. Dr. Joe Steenbrook wrote an article. Top 10 wrong things you can do. Basically, a vented crawl space is one of those. You just don't want to do it anymore. You want to be able to bring that space into the envelope and control what's going on below the home. This is a great resource if anybody wants to learn more about how temperature and relative humidity and dew point can affect their homes. It's BOPT, forget that. It's DP Calc, DPCalc.org. I think it is. It's either .org or .com. But you can play with these inputs, the temperature and RH, and it's going to give you the dew point. And if you go on the right side there, it's going to basically tell you how many days you have till a mold risk based on those conditions.
Wow.
So great resource to have. Another good resource that I'm going to just put up here quick is this residential energy dynamics, because a lot of people are concerned about how much energy their dehumidifier is going to use. So you can use their ventilation electrical usage. I just put the watts in of a 98-pint dehumidifier, how many days of the year I was going to use it, and how many minutes of every hour it was going to run, and then my kilowatts. And basically, if I were to run this dehumidifier 20 minutes of every hour, 270 days a year at 11 kilowatts, it's going to cost me $159 to run this dehumidifier.
For the year.
For the year. For 270 days of the year. I'm daydreaming. I'm living somewhere where it's obviously very nice and hot and humid for a long period of time. So, in the words of Dr. Joe, you can't energy conserve your way to dry. It's going to cost you money in order to be able to maintain that healthy, comfortable moisture levels in your home. So just like ventilation, it's an energy penalty, but we're not doing it to save energy. We're doing it because we care about the indoor air quality in a home.
Awesome. So can I call you directly to get some humidifiers in my house?
Dehumidifiers, you can, yeah.
I have enough humidity. Dehumidifiers in my house.
Yeah, it's, we've got a lot of information on our website. Sizing is a big one. We get that call quite a bit on, what size do I need? And we're very conservative in our recommendations on what size. So 95% of the time, what we have will work, but just educating. And again, you need to understand what's going on in your house, as a whole to know if, is my first step adding a dehumidifier?
Right.
Or maybe should I be air sealing first and then going from there?
So you're going to be in Washington, D.C. with us October 15th through the 17th. So people can meet you there, right?
I will. Absolutely.
And are you going to be talking, demonstrating, or just attending?
Just attending, just hanging out. Yep. Learning more. I always learn a ton at these events. So I'm excited.
And if people want to get a hold of you while you're there, what's the best way to reach out to you?
My email is nkrueger, KRUEGER at Thermastor. That's a tough one. THERMASTOR.com.
Love it. You're brave putting your email out there.
Oh, I love answering questions. That's where I spend most of my time. And the more we can educate, the better.
Yeah, for sure. For sure. I agree with that. All right, let's go to a couple quick comments here. Peter Bonar says, Dave Cooper, will your house be built properly as an airtight, well insulated, high performance home with a comfortable ventilation?
I like that.
It will be. I can promise you it will be. In fact, I have such a hard time now after doing this show and traveling the world and seeing how other people are, really putting the science behind building, that even when I see site built homes now, I just drive by and I'm like, oh, what are we doing? But it's the lack of education. Not that they're bad. It's just they could be better.
They could be better.
We can always
be able to control. I mean, what you want is ultimate control when you're inside your house after it's built.
Absolutely. Adam White says, hey, what's happening, Adam White? And of course, the immediate past chair of the NAHB. Nikki, don't let Dave fool you with a glass of water. He uses a beer glass to prove his theories. Great show.
I was going to say that, but I let you roll with the water.
Greg's going to be at the Building Systems Summit. So if those of you want to meet Greg, he will be there, I think, for the cocktail hour or what have you, with some of the other folks from Washington, D.C. And that's going to be awesome. Nikki, is there anything we didn't cover today that you want to make sure everybody knows about you, the systems, or what's happening out in the world?
I think I covered a lot. I'll let people digest that and see if they have any questions for me. There's a lot to it, but it's all fun.
It is all fun, very much so. So, all right, well, cool. Thank you so much. Stay right there. I'll come back to you after the show, so don't go anywhere. The rest of you out there, it's Friday. Make sure you enjoy some time with your family, your friends, your loved ones. I am on my way back to Los Angeles. You might just see me on a 100-foot yacht. I know. What does that have to do with building? Well, just stay tuned. You might find out what it has to do with building, but that's what we're going to be doing. So I'm Dave Cooper. Nikki Kruger, thank you so much. We'll come back to you in a moment. Enjoy your weekend, everybody. Bye now. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.